Okay, so for 8, just because of the parent function being a quadratic, it's continuous everywhere. Our domain is negative infinity to infinity. Therefore, we would just say 8 is continuous everywhere. We also said question 9. 9 is one in particular that I would have looked at the graph of it based off of what the heck's going on in here with the restrictions. I probably would not have graphed it on a calculator. And here is why. Because of things like this bottom line, the 5 where x is equal to -3, your calculator's not going to show that, because if it's just at an x equals, what is that in the graph?
Is it a vertical line? A dot.
It's actually just a dot, right? And your calculator is not going to show dots. So here is what this piecewise function is telling you. Your function is defined as x squared minus 2. This is a quadratic, should be easy for us to graph. X squared minus 2 means it has a vertex at 0, -2, would look something like this. And it is defined for x is not equal to -3. What is that telling me?
It's everywhere but -3.
Yes, it's everywhere but -3, which means that at -3, I'm going to have something there, a hole in the graph. All right. And at -3, excuse me. I'm going to erase this a second because someone else is trying to join. And then I will be right back. All right. So we said for question 9, we have, and I'll try to draw a little bit of a better graph for this. The vertex would be at -2. It would look something like this because it has a slope of 1. It would look something like that, but it's defined for everywhere except -3. So that means that at -3, we would have a hole. And then our second part of that says it's defined as 5 for just x equals -3. So this means 1, 2, 3, 4, 5, that at that point, we would have a dot something like that. It's not going to be on the quadratic. It's just going to be a random floating dot. That's all it is. So then what would we say, given that graph, about whether our function is continuous or not, and where? Is our function fully continuous?
No.
No, not. And at what place is it not continuous?
-3.
Right. So then I just have to figure out the reasoning on that. All right. So if I go through, I would say f of x is discontinuous at x equals -3. Now I need a reason. So if I'm going through, I'm going to kind of go through my checklist to the side. My checklist is f of -3 must exist. Does f of -3 exist according to that graph? There's a hole on the quadratic, but is there a value at -3?
Yes.
Yes. In fact, it equals 5. So we have a function value. 2, if I looked back at that graph, do I have a limit as x approaches -3? I would track in the quadratic from the left and I would track in the quadratic from the right, and we would say, I mean, I don't necessarily know the number, but it's, yeah, we have a function value or a limit at that because both the left side and the right side of the quadratic come into the same place. Now, here's the third check mark item. Does f of -3 equal the limit? Anyone know? According to that graph that we had, does f of -3 equal the limit?
No.
No, because we had our quadratic and we said it looks something like this, and I don't really know whether it's above or below that 5, but that 5 is a floating dot, and that's certainly not going to be the same value as the quadratic itself, right? All right. So I would say that would be my reasoning. F is discontinuous at x equals -3 because that one is not true. And that would be my reasoning for that. Okay.
Miss Leininger?
Yeah.
Real quick question. If we got the first part on the test right, if we said it's discontinuous and the answer is right, but we got the reason wrong, would you like count half off or
Yeah,
the whole
it's going to be partial credit for those.
Oh, okay.
So each drop down will be worth its own thing. So things that I would know for sure is that if I picked continuous, then this must be my reason for it. There's no other reason for continuous. The limit exists, the function value exists, and they're equal. That's my only reason for that. So if you pick continuous, then it should be a gimme as to which reason you pick, right? Discontinuous, yes, you have a couple options. Rule of thumb, pick the first one that does not work. Go through these in order and pick the first one that doesn't work.
Okay.
That's always what I do. But
Miss Leininger?
Yeah.
If we have like an asymptote, which one is that? Like, which explanation is that?
I would actually pick the first one. It's for multiple reasons, really. It's really because the function value doesn't exist and the limit doesn't exist. But for the purposes of like going through and picking one, do
Mhm.
the first one.
Okay, and then on the chart,
Mm-hmm.
in like on like number 5,
Yep.
when like the left hand and right hand limit are the same,
Yep.
so then obviously the normal limit is the same,
Right.
but the output is different.
Mm-hmm.
Is it discontinuous still?
Yes. And it's because of reason C. Because
Okay.
the limit and the function value have to be the same number for it to be continuous.
Okay.
Yes. Other questions on continuity? All right. Now, other generic questions about the test. Last like official test. I mean, there's a
Can we
test
do
grade
some-
with the project thing, but
Could we just do some like practice problems over trig limits?
trig limits. Yeah, we can. Do you want me to go? That stuff is hard to find stuff on. That's why I ended up doing that homework page, and then it was a little too much because I actually didn't have anything in here with that. Let me find the homework, and we can look at any of those. I will just say I didn't go real complicated on the trig limits. On that page, there were some that I would have expected you to be able to do, and then there was others that I would have been like, I mean, that might be a little difficult. So I went rather reasonable, if that helps your feelings on that at all. Your homework on that was this. Honestly, I kind of felt like this little section in here wasn't too bad, like A through D. Here's my goal for trig limits. Be able to do a little bit of manipulation using your formulas and then know the two special trig limits. The sine x over x equals 0 and 1 minus or equals 1 and 1 minus cosine x over x equals 0. So that's my large goal on trig limits. There's like 2 questions on them. Were there any of these 4, or do you want to look at something on the other page?
I guess the other page because they had like harder ones on them.
Yeah. I mean, okay, so generically speaking, something like 1C, I would consider to be a pretty decent level question, probably because it includes a special trig limit and a little bit of manipulation. So like if you were looking at 1C, what would you do first? Anyone can answer.
Make the tan a sine of a
So it's a small amount of manipulation. Make your tangent a sine over a cosine. So I would go ahead and immediately switch that out to sine x over cosine x. It's still over 4x. What could we do next with this? Where does the 4x go if I flip and multiply?
times the cosine.
So that makes it sine x over 4x cosine x. All right. So now within this, my goal
Or
then
could
is
you
typically,
separate them?
what's that?
Could you separate them?
Yes, exactly. Separate them. So I would separate this, and how would you separate it?
Sin x over 4x times 1 over cosine x.
I would indeed separate it that way because this includes a special trig limit. The sine x over x is 1. So what does this turn into with my special trig limits?
1/4.
1/4. And is it okay, because my limit was as x is approaching 0, to plug in 0 to a cosine?
It equals 1.
It does equal 1, and that gives me 1/4. So this is like what I would consider to be a good trig limit question. It had
Then-
one manipulation. It required you to plug in a value for cosine, and it required you to know a special trig limit. But it wasn't like crazy hard, I hope.
Mm-mm.
Is that like a decent example of one?
What are some ones that you wouldn't probably give us on a test?
Oh, like 1D, that is a little bit much because of the cube and the sign. And I mean, I personally don't remember like that form of one. I know how to do it if I need to, but it's not like a form that I remember.
Okay.
I think something like 1A, 1G, 1H are really fair because really all you have to know is the special trig limit to do those. Let me see if there's one with a cosine. Is 3F that hard? I'm trying to think. 3C is like super easy. It's just knowing the special trig limit. Let's see. Like 3B is probably even a little bit too much manipulation for me at this point. We haven't been together, so it's been a little bit hard. Like I probably would have gone harder with this if we had been in class together because we could have really practiced. Like this would have been a get up at the whiteboard and practice a bunch of these till you did them. Let's see. 3F might be a decent one, but I don't remember. Because I would have just made that tangent sine over cosine, flipped and multiplied, but even that might have turned into something funky because it didn't have all the x's. I really think stuff that like came out of 1 was more my line of what I was looking at. Like C is like the perfect, this is what I like type question. L, 1L is not bad because of the tangent being a sine over a cosine. Like I said, I like 1A because it's not exactly the special trig limit. You have to remember that 5 rule that we did, multiplying by 5 front, top and bottom so that the sine x over the x matches. Let's see what else. Honestly, like 3J is not that bad. You would factor and then split. Yes, ma'am?
Avery wanted me to ask you to let her into the call.
Oh.
I think she's in the waiting room.
I didn't hear the noise. Okay, got it. Yeah, so like 3J would be another good example real quick if I was doing another one. I would in that one, that top is a difference of squares. And then I would probably just go ahead at the same time and split that up because of the x squared. Because then you get a 1 minus cosine x and a 1 plus cosine x. Well, that still is a mess because of the x on the bottom with the other one. Oh no, that instead of factoring, that one was a good substitution one. See what I do to myself? But yes, that's still not a bad one because you would substitute 1 minus cosine squared is the same as sine squared. And then that's just a split. Sine x over x and sine x over x. Both of those are 1. So that is a decent level 1 as well.
What about like 3I or 3L?
I don't think I went there because of the double angle.
Okay.
I feel like I went pretty simple on these,
Okay.
honestly. I'm not trying to like be super tricky. The homework was a little bit harder. but that doesn't always mean I'm going to do. I mean, I think you guys know, like, if you look at what we did and then look at the quiz level, like, did we all feel like, all right, maybe we went a little bit up, but then the quiz was pretty doable?
Mhm.
I mean, the quiz grades were great. I thought they were good for, I mean, distance learning. Other things that we're not sure about from like what we've talked about? Or do you just want me to go through like what's on it? Not like exactly what's on it, but yeah.
I have a 9.5 question.
Yeah.
So I kind of missed the first 10 minutes, so this might have been
Yeah,
answered.
it's okay.
But
Bring it back.
in general, so whenever, let me pull it up.
Yeah, I'm pulling mine up.
So okay, so on questions like number 8, like I know it's continuous. Will there ever be one that's like not a fraction that is discontinuous?
Let's see. Rational functions, no. Cubics are fine. No, like out of the list of the parent functions that we've talked about, linear is always going to be continuous, quadratic, exponential, logarithmic. There would be like domain restrictions on a square root one just because it would start at a certain point and continue, but we still can consider that continuous. There's no holes or asymptotes. No, other than rational functions, no. So when I briefly talked about that at the beginning, I kind of said in my mind, I'm looking for fractions. That's a problem because of asymptotes and holes. Piecewise functions tend to be a problem like at their restrictions where they come together. And then beyond that, there's really not much.
Okay. And then on questions like 9 and 10, so I know 9, both pieces have like -3, and then on 10, both pieces revolve around 1. Will you give us any of the ones that are like 3 different piecewise functions and like they all involve different numbers?
Yeah, because I did that on the first quiz just for like finding the left side and the right side limit. Like that would show up there.
Okay, so then you would specify like which one it's approaching.
Yes.
So like X is approaching like 2 or 3. Okay.
You would just have to know which part to plug it into. So yeah, going back to kind of like a list, be able to do one of those big graphs. That was on the quiz, but that's also been in your notes. And there were some extra ones in your notes that we didn't do all of. So like, and when I say the big graphs, like where I give the big piecewise function and you find the pieces, honestly, like I love questions like that because Photomath, Mathway, all of that can't help you on that one. So, you know, that's my way of figuring out if you really know what you're talking about with graphs. We did piecewise functions of our own. So like we were just talking about, I could give you a piecewise function and have you find the left, the right. Honestly, expect it to be set up very much like the quiz. So the quiz was 10 questions. I did a graph. I did a piecewise function. I did a just plug it in. I did a factoring. I did a conjugate. I did a complex fraction. This then would add in trig limits and limits at infinity, and then expect the continuous stuff. And I kind of already said like the continuous stuff will be similar to this table. I literally did like drop down menus. So you don't even have to type in like limit does not exist or anything like that. I'm not trying to mess with however everyone could type that. That's a big mess. So I've literally made a graph like this, and I'm going to say at x equals -2. You pick continuous or discontinuous, and you pick which of those 4 reasons. And I've typed them exactly like these 4 reasons here so that it's something familiar and it's not weird notation. So that's what I would see with continuous and discontinuous. And like I said, I added in trig limits and limits at infinity. I think it's 13 questions, and the 14th is upload your work.
What is the tricks at the infinity again?
The limits at infinity was what we did with, we didn't use these notes, but I can go back to this. We did Bobo Button eats DC, and we said if the exponents are the same, you divide your coefficients. Your horizontal asymptote would be 3/2. So as you head out to infinity, that's what your limit is approaching. The homework that we did on it was, let me pull it up.
Also, when it says like limit approaches infinity, that means it's like x is approaching infinity, and we're just telling it the y.
Yes. So when it says the limit as x approaches infinity, it's saying look at the right side of the graph and tell me what's going on. It's very, very much like end behavior, honestly.
Yeah.
So you're telling me as the x goes to infinity right here, what does the y do? Yes. And often the horizontal asymptotes will tell us that if you're in a case like 2, A, B, C, and G, H, and I. And if it's just a polynomial like this, you're going to just know it from the end behavior chart that we talked about.
Okay. And
If I make it,
Yep.
I have a question on one of those.
Mhm.
So on ones like 2G, where it's bigger on top,
Yep.
and so that means there's no horizontal asymptote, so it's going to be like infinity or negative infinity. And you tell that by,
Calculator to check your graph on that one. I mean,
okay,
I could force you to graph it, but I'm
so
also,
we should probably just use the calculator for those. If
yeah.
it comes to like none.
Because what
Okay.
I will most likely do, or how I've most likely the test is already written. Most likely, if it is something that like is the other two cases, Bobo button needs DC or 0, I'm going to try to, well, 0 is obvious, but I'm going to make Bobo button needs DC something that like you're not going to look at your calculator and guess this number. You'd have to actually know to do Bobo button needs DC and divide the coefficients to give you the answer. That will be kind of how I set those up. Just, I know you have calculators, but yes, for ones like that, definitely use your calculator, and I would expect that because I'm not asking you to regraph all of those at this point. So
For a question like 2E, you say we use, that's using the end behavior stuff?
Yeah, 2E is a little bit different because it is a rational function, but they all have different denominators. So that's where the ones that have x on the bottom, these you can use Bobobot and eats DC for these two particular parts, which means these both go to 0. But this, the cubic kind of throws things off because it goes to infinity if you plug it in, or negative infinity. So I would worry more about the, I wish I could highlight that, but I can't. In that particular one, I don't worry about these terms because these both go to 0. This is the one that kind of throws things off there.
Okay, so that's regular positive infinity?
That's a negative leading coefficient and an odd, so it would go to negative infinity only because the right side goes down.
Okay.
Yeah. Other questions? No? And then after that, guys, I don't have plans to do live sessions because there's really only 2 sections left. And there's videos, and I'm kind of letting this be self-paced. That's not to say that if you're like struggling on something, you can definitely let me know. But this is the group work part of it, and you guys chose your groups. You do whatever you want with that. If you didn't sign up for a group yet, make sure you know how to do that. Let me see if I can pull mine up real quick for you. Let's see. I'm going to share this. If you have not signed up with the group, what's that?
If one person is signed up for a group,
I think you guys are.
we all have to sign up.
I think you guys got it. You do have to all sign up because of submitting. It like allows you to like submit as a group for that, so that I don't expect something from you. But this is where under people, and then there's a unit 10 groups thing. And this is seniors, you don't have to do this, so don't worry about it. And you can sign up for whichever group you want. I have some that are 1 person, 2 people, 3 people, etc. So I have that kind of all set up so that you can sign up wherever you want. But then it's self-paced. Literally, if I'm looking at this module 10 down here, unit 10, you have, there's basically 3 things in it. Lesson 10.1 is very basic polar coordinates and the homework. It's not real long. Lesson 10.2 is there. Someone let me know today that the video wasn't attached, so it is now. And the homework for that. There's a polar graph investigation thing. I would suggest doing that together if you can. That, let me just kind of show you that if I pull that up. Oh, did I not attach this? Nope, it's in your notebook. That's what it is. I'm a genius. If you look at that, and I will share that now so that you can see this. The group activity, this isn't like the test grade. This is just to get the idea of polar graphs is at the very, not this unit. I am doing so well right now. Let me find this. Sorry, guys. Where is this for me? This is it's like a, have you guys used Desmos before? It's a graphing software online.
I believe we have a couple of times.
Yeah. It's actually a decent activity for learning the basic idea of polar graphs. So let me see. There we are. Should have been prepared for this. I was not. Excellent. We have something that looks like this in our notebooks. This is the website right up here at the top, and there it goes. So it will open up Desmos for you, and it has polar graphing here. So then you can use the sliders and kind of work through. It's attached by problem set 1, problem set 2, problem set 3. But this is something that if you were working with people, that I would do this together. If you can, do it on Zoom, share a screen. I know it's a little bit hard to do because we're not all together. We would have done this in class. And at the end of this, there is a summary page. Let me grab that so you can see that too. The summary page looks like this. And it's just to get a good idea of the different types of polar graphs and what their basics are. I will just say that what you do with this and the first 2 assignments definitely determine how much of the test grade you're going to be able to do. Like this is a note sheet that you can then use on that test grade as a group. So it's something I would definitely recommend doing so that you know what you're talking about going into it. But the way I've done it is just everything is due by the 22nd. So that is just totally up to you guys when you do that. It kind of gives the freedom around the AP tests and all of that, if that helps. I hope. It's my intention to make it the last couple things. So any questions from anyone before we jump off?